Hi, we're going to look at a bunch of series type of questions, seriesly, and take a look. If you need to take a look at these, copy these down, by all means do so. For the very first question here, it says we want to find the radius and interval of convergence. So this is using our ratio test. So if we go ahead and start setting this up here, we would take the limit as n goes to infinity. And remember, we want to use the ratio test because the ratio test guarantees that a series will converge if we take the limit as n goes to infinity of the next term divided by the original term if that ratio is less than 1. So that's what we're trying to do here. So if I look at the next term, we would get this x minus 5 to the n plus 1 over n plus 1 times 3 to the n plus 1, and I'm going to invert that. N times 3 to the n over x minus 5 to the n. We want to make sure that that's less than 1 right there. So this is what we're trying to guarantee. We're trying to show that this is going to be less than 1 right here. There is my next term, and there's my original term. When we're dividing them, we're going to invert and multiply, so that's why I wrote it as a times problem right there. So solving this one now, I am just going to kind of clean this up a little bit as n goes to infinity. I'm left with 1x minus 5 on top. I can't do anything with the n here and the n plus 1, so they're just going to stay n and n plus 1. But if I look at the 3's, I got 3 to the n here and 3 to the n plus 1 here. And if I reduce it, I just get a 3 on bottom, and that's going to be less than 1. All right, now we're only interested in as n goes to infinity, so we're really not worried about the x or the 3, so I can kind of factor that out. I'm going to go ahead and do that, so right there. And that's going to give me the absolute value of x minus 5 over 3. And that's really nice for us since it's over 3. All that's kind of telling us is that what's left on the inside is the limit as n goes to infinity. Sorry, that's what I was going to say. We don't have to put the 3 in the absolute value because 3 is already positive. There we go. And we put this n over n plus 1 is less than 1. And our limit as n goes to infinity of this right here is just 1 right there. It's just 1. So what we're left with is x minus 5 over 3 is less than 1. Now we're ready to start solving. So I'm going to worry about this one at a later time. So if we want to find the radius is going to, if I multiply by 3, we're going to get the absolute value of x minus 5 is less than 3. That 3 is our radius. And what that tells us is from our center at 5, remember, there's my center here at 5. From our center at 5, we can go right 3 or we can go left 3. So anything between 2 and 8 is guaranteed to converge. And you can solve this algebraically if you wanted to. That would give us x minus 5 is between 3 and negative 3. So x is between 2 and 8 if you needed to. Now, the only problem is, remember, the ratio test guarantees convergence if less than 1. But what if it was equal to 1? So now we have to check our endpoints. And this is the hard part. So we're going to check our endpoints right now. To get the endpoints, the first endpoint is 2. And we're going to plug it into our series right here. This becomes then negative 3 to the n over n times 3 to the n. And if I clean that up a little bit, negative 1 to infinity, this is negative 1 to the n, 3 to the n over n times 3 to the n. And those will cancel. This is an alternating series, so it will converge. So we can say that the series alternates, decreases in magnitude, and the limit equals 0. Therefore, this converges by alternating series test. So 2 works. Now we have to check x equals 3. I'm sorry, 8. Sorry about that. And if we plug that into the original, we would get over here 8 minus 5, which is 3 over. So we would get 3 to the n over n times 3 to the n. And notice we're left with a p series. P is 1, therefore this diverges by p series. I should have given myself more room here. So 8 does not work. So at the final end, we're looking at the interval now. So our interval, well, we originally said it's going to go between 2 and 8. But 8 didn't work, but 2 does, so I put a little bracket, a little bar underneath that. So there's our interval and our radius. Don't forget what's 3. And the center, we should always list out the center too. So center was 5. And there's our answer. Very easy to do. All right, the next one, number 3. We'll do number 2 later on. We want to find the sum of this series. So I just want to take a look. If I look at one, it's alternating, and I notice the pattern. Notice it's 1 over 3 factorial, 5 factorial, 7 factorial. And if I look at the pattern here, this looks kind of like cosine. Like sine. I'm thinking this is sine of x. Well, what is sine of x? Sine of x is just 1, is just x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. And I think I've seen enough right there. That should be a minus right there. I think I've seen enough. So take a look. All they've done is they replaced each x with 1. So that's all we did. Replace x with 1. And therefore, this becomes the sine of 1. And there's our answer. If I replace each one of these x's with 1, I would get the exact same thing as up top. So that's just the sine of 1. All right, the next one's a kind of really fun question for us. It says, what's the value of this series? So now, normally we don't know what the value of a series is, but if I do a little bit of math here on the top here, n equals 0 to infinity, we get 3 to the n times 3 over 4 to the n. And I can do that, just my algebra work right there. And, oops, 4 to the n. And let's see here. If we go 0 to infinity, I can now write this as 3 times 3 over 4 to the n. And if I notice, this is geometric. Now, this has shown up on the AP a couple times recently right there. So that's a geometric series. So how do I find the sum of a geometric series? Well, that's just our first term over 1 minus r. So therefore, my first term, if we let n be 0, this just becomes 3. Our common ratio is 3/4. So therefore, the value of our integral is just the sum, which is 3 over 1 minus 3/4, which is just 12. Right there. Very easy to do. All right. Number 5, we want a function has a Maclaurin series of the following. What is f of x? So this is very similar to what we did for number 3. We want to find the original function for this. And let's see here what's kind of going on here. Let's see. So we want to find out what this looks like. So if I look at the top here, we got this x squared. Hold on here. We got this x, whoops, sorry. We have x squared minus x to the 4th over 3 factorial, and so on and so forth. And I'm starting thinking, oh, on the top here, on the bottom, again, it looks like sine of x. So the bottom, so again, if I think of sine of x as just x minus x cubed over 3 factorial plus x to the 5th over 5 factorial, I think I've seen enough. Minus there. Notice the only difference is we're just multiplying each numerator by x. Instead of x, we get x squared. X cubed becomes x to the 4th. So therefore, if I multiply this by x, sine of x, it's like our Maclaurin, because again, it's Maclaurin, so I'm thinking my shortcuts. This becomes x squared minus x to the 4th over 3 factorial plus x to the 6 over 5 factorial minus dot dot dot. So therefore, this series right here, f of x, is just x times sine of x. And there we have that. Very easy to do. All right, number 6. All right, this says, if f is a function given this derivative, find the coefficient x to the 7th of the Taylor for f of x. So x equals 0. So we're thinking Maclaurin. So this is Maclaurin, so I can use my shortcuts. So f prime of x is just cosine of x cubed. Well, I know cosine of x is my evens. So that's 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6 over 6 factorial plus dot dot dot. I want x cubed, so cosine of x cubed is going to be 1 minus x to the 6th over 2 factorial plus x to the 12th over 4 factorial. And I can stop there because I want the x to the 7th term. I'm already beyond that. So but be careful, I want f of x. Remember, this is f prime. So to get f of x, we would integrate this. 1 minus x to the 6 over 2 factorial plus x to the 12th over 4 factorial plus dot, 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 dx, some dx right there. And if I do that, what are we going to get? We would get x minus x to the 7th over 2 factorial plus times 7, oops, sorry, I forgot to drop my power there, plus x to the 13 over 13 times 4 factorial plus dot, dot, dot. Don't forget at the very end there's some constant integration. We wanted the 7th term, so the coefficient for the x to the 7th term is going to be the following. Oh, there it is. What's my coefficient? It's just it's negative 1 over 7 times 2 factorial. And there's our answer right there, which, if you simplify, that is negative 1 over 14. All right. Hope you enjoyed this video. Go to video number 2 and take a look at a few more. See you then.